Good morning, students. So, today again our topic is light energy, which is your chapter 4. And today I am taking the topic from the chapter light energy is the reflection of ray of light normally incident on a plane mirror. Okay, so now let us take a plane mirror. Consider a ray of light AO normally incident on a plane mirror M and M1. So this is a plane mirror M and M1. Then a ray of light is reflected from this angle, okay, which is the normal line. Okay, so when we are reflecting the ray of light from the normal, okay, at a point of incident O, okay, when the light is reflected normally at the point of incident O, so the angle of incidence is measured normal to the mirror is 0, okay, because there is no angle forming between the angle of incidence and normal, so I is equals to 0, as you can see it over here. Now, according to the law of reflection of light, okay, the angle of reflection of light R will also be 0. Why? Because as we know that if the light is reflected from this direction at the point O, okay, at this direction, see, at this point, so it is reflected over from here, but we are taking the reflection of light from this point A point, and it is falling straight on the point of incidence. So here there is no angle of incidence, and according to the law of reflection, angle of incidence is equals to angle of reflection. So there is no angle of incidence, so there will be no angle of reflection also. Means I equals to R, means I equals to R equals to 0. Clear? This is according to the law of reflection. So it's simply show that the ray of light incident normally after reflection from the plane mirror retraces its own path. Means if the angle of incident is coming from the normal, okay, normal point, so it is retracing its own path. It is not reflecting towards any side, but from which path it is coming, it is again going on the similar path. So this is your reflection of ray of light normally incident on a plane mirror. Okay, I hope you have understood it. Let's see the next one.
Reflection of light by plane mirror. Case 1. The object is of point size. Let us consider a point object O placed in front of the plane mirror. A ray OA, which is falling on a plane mirror at 90 degrees, gets reflected back on the same path AO. Another ray ON, falling on a plane mirror at any angle of incidence, gets reflected such that the angle of reflection is same as that of angle of incidence. Now produce BN and OA in back of mirror, so O dash be the reflected image of O. Thus O dash be the image of point object O. The distance of object from the mirror is same as that of distance between image and mirror. Reflection of light by plane mirror. Case 2. The object is of extended size. Let us consider an extended object AB is placed in front of the plane mirror. A ray BC, which is falling on a plane mirror at 90 degrees, gets reflected back on the same path CB. Another ray BP falling on a plane mirror at any angle of incidence gets reflected such that the angle of reflection is same as that of angle of incidence. Now produce XP and BC in back of mirror, so B dash be the reflected image of B. Another ray AP falling on a plane mirror at 90 degrees gets reflected back on the same path PA, and ray AQ reflected as QY produce YQ and AP in back, so A dash be the reflected image of A. Thus, A dash B dash be the same as AB. The nature of image is erect, virtual, same size, and laterally inverted. The distance of object from the mirror is same as that of distance between image and mirror.